Assalamu alaikum. In this video, we are going to go over this formula list and try to use each of this formula in a mathematical question. All right. So the first formula here we have S is equal to range over 4. We go to the slides. All right. So here the question is the heights in inches of students in a class are approximately normally distributed with a mean of 65 and a range of 20 inches. Now it is asking, using the range rule of thumb, estimate the standard deviation of the heights. We have the mean given as it is a population. All right, we are using the symbol. We're saying 65 inches, that is the mean, and the range is 20 inches. So if the range is not given in the question, you can go to the formula list. You will find this one, R is equal to highest value minus lowest value. So if you categorize the data or sort the data in ascending order, you will find the lowest value and the highest value. From there you can get the range. So according to the formula, we substitute the value of R, which is 20. We get 20 over 4, which is 5. So the estimated standard deviation here is 5, and the data mean is given, but you do not actually need to use it, but it's just given there. All right, so that's our formula 1, and then we have the formula 2, which is the C bar is equal to standard deviation by mean times 100. We go to a question. The question is, the weights of two different types of fruits are being compared, apples and oranges. The mean weight of apples is 150 grams. So you see the mean of apple is given 150. Then the standard deviation is 20. For the next one, orange, the mean weight is given 200 and the standard deviation is given 30 grams. The question asks to calculate and compare the coefficients of variation for both types of fruit. So we write down what we have is the mean of apples, the standard deviation, the mean of oranges, and the standard deviation of oranges. Then we use this formula, the second one, C bar. Okay, C bar is equal to standard deviation divided by mean times 100. So for apple it's 20 divided by 150 by 100%, and we get the result as 13.33. For oranges we get 15%. So now we compare the coefficients of this coefficient of variation. The coefficient of variation for apple is this one, and this is for orange. And since the coefficient of variation for orange is higher than that of apples, we can conclude that the weights of oranges are relatively more variable compared to weights of apples. Okay, this is the second use of the second formula. The next one is IQR is equal to Q3 minus Q1, which is the interquartile range. For going to the IQR, we need to actually find the Q1, Q2 and Q3, right? Because in the formula it says IQR is equal to Q3 minus Q1. Firstly, we figure out where the Q1, Q2 and Q3 are. So this is a data set here. So firstly we have to arrange the data set according to ascending order. So we do it from lowest to highest. We get this data stream. Now we want to find the median of this data stream, which will be our Q2. So as this is an even number of data, so 1 2 3 4 5 6 7 8 9 10, we have equal numbers of data. So we add the middle two data, 18 plus 19 divided by 2, we get the median of 18.5. Now we want the Q1, which will be the first datas or datas below 18.5. So here we have 1 2 3 4 5 here. So as this is an odd number, we get the median 15, which will be our Q1, and for the next one above 18.5 or above Q2 will be also odd numbers. We get 22. So now our Q1 is 15, Q2 is 18.5, and Q3 is 22. Where do we use this, or the IQR, right? Now for this one, I think the numbers are different, but the idea is same. You get you sort them into ascending order, then find Q1, Q2 and Q3. Then IQR, we get Q3 minus Q1. In this math equation we get 20 minus 9, which is 11. Now this is our IQR value. If we multiply the IQR with 1.5, right, we get 16.5. You may based on your equation you will get something else. Where you add it to your Q3 and you subtract it from your Q1. So in our this specific question, the Q1 is 9. So we subtract 16.5 from 9, we get negative 7.5, and we add 16.5 to 20, which is our Q3, we get 36.5. So any in this data set, any data that is below negative 7.5 or above 16.5 will be the outliers. For this instant, the value 50 is out of this interval, right, from negative 7.5 until 36.5. So the value 50 in this case will be an outlier. Okay, so the question can ask to identify the outliers in a data set. So in that scenario, you have to find the Q1, Q2, Q3, then the IQR, multiply the IQR by 1.5, add this value to Q3 and subtract this value from Q1, you will get a range, and whatever data is outside that range will be called an outlier. We go to the next function, which is x is equal to summation of fxm by n. So this is a formula for mean, okay, mean or average in a group data. So we consider this problem, consider the following frequency table. We have the class interval and we have the frequency, right? We first have to calculate the midpoint of each class interval. So this is 10, 20, so we get the midpoint by 20 minus 20 plus 10 divided by 2 is equal to 15. You can find this formula here as well. X midpoint is equal to lower boundary plus upper boundary divided by 2. So we get here the midpoint of classes, first class, second, third and fourth, all of the class intervals, we get the midpoints. Now in the formula it says the summation of f and x to the xm multiplication, right? So we multiply 5, the first frequency, with the first midpoint class 15, then we add it to the second one, 8 times 25, then we do 6 times 35, then we do 4 times 45, and then we add all these multiplications to get the f times xm. All right, here in this scenario we will get 665, and we substitute this value into our formula. This formula, the x is equal the mean is equal to summation of xm by n. We substitute this, the n we sum of all the frequencies, so 5, 8, 6, 4, we sum them up, we get 23. So the approximate mean is 28.91. all right, so that's the next formula for mean. And after that we have this formula which is for the standard deviation of a population. You have to take note, the standard deviation and variance of population and sample will be different, and the symbols will be different as well. We go to question. So the question is, consider a population of exam scores with the following values: 80, 85, 90, 95, 100 and so on. Calculate the population variance and standard deviation. Here in the question it's specifically specified that this is a population of exam score, so you have to use the population formula, which is this one. All right, we substitute the variables here. So first things first, we need to calculate the mean. How do we calculate the mean? As this is individual data, we add all of them up and divide by the number of data. So we have 5 data, we get 90. The mean is equal to 90. Next we calculate the squared difference between each data point and the population mean. We get 80 minus 90 is the mean, right? Why we are doing 80 minus 90 square? If you go back to the formula, it says on the top x minus mean whole square, right? So that's what we are calculating. This one we are calculating the first value, 80 minus mean 90 whole square is equal to 100. Then we are doing the next one, the value is 85, so we substitute x with 85, then subtract the mean, which is 90, then whole square is equal to 25. So we do it for all of the values. Now we have this summation. We sum all the individual status that we get: 100, 25, 0, 25, 100. We add them up, we get 250. Now we try to substitute it in the formula. On the top we get 250 because we already sum all the whole squares, right? We get 250, and on the bottom we get n is equal to 5 is equal to, once we divide we get 50. Now you may say that in the formula we have a root over, right? So root over means that it is a standard deviation, and here without the root over or this variance, standard deviation square is variance is 50. We want the standard deviation, so we square root the answer. In this scenario 50, we get 7.07. So the answer will be population variance will be 50 and the standard deviation will be 7.07. All right, this is the use of this formula. Next we have the weighted mean formula, where we multiply the weight with the x as well as we divide it by the summation of x. If we see example of this weighted mean, okay, this one, and this example is of a data set on grades. Okay, the grades are on a scale of 0 to 100 and students their corresponding score. So grade is 80, we got this credits is 3, then we have 90, the credit is 4, we have 85, the credit is 3, there should be a space here. All right, and 95 we have the credits to be 2. Now we want to calculate the mean. If we go back to the formula, we see the summation of w into x divided by the summation of w. Here w means the weight. If we go back to the math, we do 80 times 3 plus 90 times 4 plus 85 times 3 plus 95 times 2 divided by 3 plus 4 plus 3 plus 2. Then we do the calculation and we get the weighted mean to be 87.08. This function is for the weighted mean. And the next function is for the mean, which is very straightforward. You sum all the x values and divide it by the number of values. Following that, we have MR, or the mid range. We get the lowest value plus highest value divided by 2. Okay, this one is also like maybe some part of a math. It itself is not a math problem. All right. Following that, we have this function, which is the exact same function as this one. This one is for standard deviation and this one is for variance. We just do not have the root over here and have the square, so the problem will be the same one. Okay, so the formula will be the same as this one, the square one and the one without squares. One for variance, the squared one is for variance, and the without the square and the root over on the opposite side is for standard deviation. So these two formulas are similar formulas for population. One is not similar, same case formulas for population. Then we have the z, which is z score equal to x, the value, minus mean divided by standard deviation, or s. So we go to example. Here we say consider a dataset with the following values 10, 15, 20, 25, 30. Calculate the z score for the data point x equals to 20. So our value given x is 20. We need to find the mean, which is we add all of them up and divide by the number of datas, 100 by 5, 20, and the standard deviation. So we have to firstly calculate the standard deviation. We calculate it by x minus mean whole square, all right, divided by n. So we have 10 minus 20, 10 minus the mean, 20 whole square, then 15 minus 20 whole square, and so on, all of them divided by n, and we get the standard deviation to be 5 root 2, or you may get like decimal points based on your calculator. Now we want to calculate the z score for x equal to 20. So we minus 20 minus we get 20 minus 20 divided by 5 root 2. 20 minus 20 is 0. So the z score we get is 0, because indicating that it is exactly at the mean of the data set, the 20 value and the mean is the same, right? So the z score will be 0 here. You may get. Following that, the next formula is for the standard deviation of a sample. This one was standard deviation for a population. This one is standard deviation for a sample. Formulas are the same. What is the difference between these three formulas? So these two formulas are standard deviation formulas. This one is variance, this one is standard deviation. So these two are for independent data and this one is for group data. That's the difference. But these three are for sample data sets. These two are for population. So you have to take care of these two very important keywords, population and sample data set. So let's go ahead and see what this formula is about and how to use this. Okay, we go to a math. Okay, here we have a group data set. We have the number of items and we have the frequency. Firstly, we calculate the f or the frequency times the value x, or in this scenario midpoint, okay, because this is grouped x, this will be xm, right, x denominated by m, I think. Okay, so the midpoints of each of these classes. So the first class midpoint is 15, so 15 times 5, so it will be this one. Then the next class midpoint is 25, so 25 times 8, and so on, 35 times 6, 45 times 4. Then we get the summation of all of this, we get 665. The next one we want is summation of f times x square. Here we get 15 square, instead of 15 we get 15 square times 5, 25 square times 8, 35 square times 6, instead of using only 35, and then 45 square times 4. This time we get a different summation, because we are multiplying f with the square of x, or the midpoint of the group data. Also here we are just doing the midpoint times the frequency. Now we go to the formula. The formula is summation of f times x square minus f times x whole square, okay, divided by n times n minus 1. If you go to the formula list, you will see that, yeah, the root over is there, but the idea is the same. We have n times summation of f times xm, as I said, xm is the midpoint square, minus summation of f times xm whole square divided by n into n minus 1. Okay, so we substitute the values there and we get the calculation of the answer around 61.265. okay, and here we do the root over and we get 7.785 around. So this is for the standard deviation and this one is for the variance. Now if we have the sample data but in ungrouped or individual data, we will use this formula. Instead of using the midpoints, we will use the actual value of x. Okay, we go to a math problem. Here consider a sample of exam scores. You see the word sample there is important. Exam score 70, 75, 80, 85, 90. Calculate the sample variance and sample standard deviation using the alternate formula. So we have this sample, we calculate the summation of x, we add all of this 70 plus 75, 80 plus 85 and so on, we get 400. Then we try to get the summation of x square. So 70 square, 75 square, 80 square, 85 square and 90 square, we get this 31,650. Now we substitute these values into the formula. So is s square is equal to summation of x square minus x whole square by n divided by n into n minus 1, and we do the calculation. We get 3,912.5 as the s square. We root over, which is 62.55. so root over means this is the standard deviation and the previous one was the variance. If you look at this formula, so these two formulas, this formula is for variance and this formula is for standard deviation. The next one is cumulative percentage or cumulative frequency percentage. We go to a math problem and see. It is given a data set, we have a class interval, we have a frequency. It is asking us to calculate the percentage frequency for each class interval. This first class will be 21.74% and so on. So we just go ahead and straightforwardly substitute onto this formula. Then we have the next formula is the midpoint, lower boundary, upper boundary divided by 2, as I showed in other examples before. And this one is summation of x by n. It is the formula for mean. It is the same formula as this one. It's just this one is for sample and this one is for population. These two formulas are the same. Then we have the percentile. Okay, we go to an example. Percentile is number of values below x plus 0.5 divided by total number of values times 100. We go to one example for this. Okay, this one. A teacher gives a 20-point test to 10 students. The scores obtained by the students are as follows: 18, 15, 12, 6 and so on. We want to find the percentile rank of the score 12. Firstly, you do sorting of the data in ascending order. Then you count the number of values in the data set that are less than or equal to the score of our interest, or which score we are trying to find. In this case, we are trying to find 12. So you will find the data below 12, which will be 2, 3, 5, 6, 8, 10. Now we want to calculate the percentile rank, number of values less than or equal to the score plus 0.5 and total number of values in the data set, okay, times 100, I think, yeah, plus 0.5. So we have how many data? 1, 2, 3, 4, 5, 6. So 6 data plus 0.5 divide, yeah, this 0.5 is missing here. According to our formula, it will be 6 plus 0.5 divided by total number of values times 100. Okay, you will get the percentile rank. Maybe like this calculation is a bit wrong. It will be plus 0.5 here, 6.5 divided by 10. Okay, that's for the percentile rank. Then we have the Chebyshev theorem. So this one, I think in the slides we have a very good example given there, math example. I'm not going to show it anymore. This formula, the s square is equal to n times f x square m. This is the same formula as this one. This one is for standard deviation and this one is for variance. It's the same formula without the square, with the square on the other side instead of root over on this side. So we are not gonna go, for example, here r. As I showed in this example here, we need to find the range for using the rule of thumb, range rule of thumb. We get the r value from the highest value minus the lowest value. Be careful, it's not the boundary or the limit of a class, right? This is the highest value of data. So when you sort the data, you get the lowest data and the highest data. You subtract the lowest data from the highest data. All right, and this one is x midpoint. It's the same as this one. It's saying lower boundary, it's saying lower limit, depending on the scenario, but it's the same thing, same formula. This one C-var is the same formula as this one C-var. This C-var formula is for population. This C-var formula is for samples. Okay, we have the standard deviation on both cases divided by mean times 100. Then we have the cumulative percentage is equal to cumulative frequency by n times 100. All right, if you want to get the cumulative percentage of the one of the cumulative frequency, okay, you replace the cumulative frequency divided by n times 100. Then we have the degree. So if you want to know the degree of a certain frequency, we can go to one of the examples. Where is it? Okay, this one. Okay, all right. So suppose we have data set representing 50 colors of people. The frequency of each color category are as follows. Okay, and we have red 12, blue 18, green 10, yellow 6, and purple 4, and so on. So if we want to get to know the degree, we divide f, the frequency, in this case red is 12, right, divided by n, total number of frequencies. So we add 12, 18, 10, 6, 4, all of them, and get 50. We divide 12 by 50 times 360. So we get the degree 84. So let's say you want to draw a pie chart, you can get the degree of each of the frequencies to easily allocate how much degree is needed for representing red color. So in our case it will be 84.6 degrees, in blue it will be 129 degrees, and so on. And that's the formula for degree. And this z is the z score, is the same formula as this one. This formula is for sample, this formula is for population. You subtract the mean from x divided by standard deviation. And this one is class width. Class width is also the upper boundary minus the lower boundary. You need the class width to calculate median, in the formula, median and mode. Alright, so those formulas are not given here, so I think maybe they will not be covered in the quiz. I'm not sure, but yeah, class width is the difference in class. Maybe if we go here, the class width is 20 minus 10. Okay, so the class width will be 10. Similarly, 30 minus 20, 10. The class width will be the difference of higher limit by lower minus lower limit. Okay, now for the last formula, which is C is equal to n times P by 100. So let's go ahead with the example. A teacher gives 20-point test to 10 students. The score obtained by students are as follows: 18, 15, 12, 6, so on. We want to find the value corresponding to the 25th percentile, not 25th data, 25th percentile. So firstly we sort the data into ascending order, right, and we get the n, or number of data is 10. Okay, 1 2 3 4 5 6 7 8 9 10. All right, and the p, or the percentile value, is given in the question 25th, right. So the position equals n times p divided by 100. So 10 times 25 divided by 100, 2.5. Now round up the position to the next whole number. If we get decimals, and if c is not a whole number, round up to the next whole number starting at the lowest value, count over to the number that corresponds to the rounded up value. So in this scenario, if we round 2.5 to the nearest whole number, it will be 3, right. And so if we count from the ascending order, so the value 3 will be 2, 2 will be first one, 1 2 3 5, right. So counting from the lowest value, the sorted data set, the third value is 5. So the 25th percentile value will be 5. But here is a exception in this formula. If you get the result as a whole number, we go to here, and you get the you do the sorting, and you do the calculation n times p divided by 100, you get the value to be a whole number, or 3, right. In this kind of scenario, you have to do is use the value halfway between the c and the c plus 1 value. So you got 3, right. We are going to use the value 3 plus 1, 4, and 3, the value in between, as our percentile value. Okay, so we count number 3, 1 2 3, we get 15. So our first value is 15, and the second value is 15, the 3 plus 1, fourth value, which will be in this case 16. So 15 plus 15 and 16, we will use the value in between. So we have 15.5. The halfway value between is 15. It is 15.5, and the percentile score, or the 13th percentile score, will be 15.5. Rather, if you get 3 and you say the value is 15, it will be wrong. So you have to take care of, if it is a full number, you have to round, you have to take 0.5 or the middle value. It's not going to be 0.5, right. If it's 15 and 18 on the next value, right, so you have to get the middle value, 15 plus 16 by 2. Okay, so that's how you get the c values, or you get the percentile value. I think that covers all of the formulas in this formula sheet from chapter 2 to 3. That will be all from me. Thank you very much for watching this video. Assalamu alaikum warahmatullahi wabarakatuh.